Welcome. This section is actually on power rules, but here is some rules for derivatives, so we don't have to go through the whole definition of derivative. We won't have to necessarily go through the whole limit as h approaches 0 of f of x plus h minus f of x on h, like we did in our last assignment. These are our shortcuts, so this is probably what you've been, once you get calculus, this will be what you're waiting for, but you're going to do a lot of the limit work. So we're going to actually get through these four in this next section, power rule, but these first rules are really very, very basic. And the constant rule says if I have f of x equals c, for instance, f of x equals 3. Now, if f of x equals 3, our graph of that is that horizontal line. And don't forget, a derivative is about the change. To have a derivative is the change. Change is slope. What's the slope of this line? The slope of the line is 0. So if our function is just a constant, no variable, the derivative, of course, is 0. And a constant multiple. Let's say, for instance, g of x is x squared. And let's say f of x is, or c is 4. In the past, we would say the graph of this looks just like x squared, except 4 times as tall. If it's 4 times as tall, then the slope must be 4 times as much. So when we're taking the derivative, if I'm taking the derivative of 4x squared, that guy's derivative, we'll use that for derivative symbol, then it's the same as, it's 4 times as tall as the derivative of x squared. Okay? You'll see this, and once you see some examples, it'll make a lot of sense. This is really, could just be called the distribution rule. If I'm taking the derivative of a function plus a function, if function is a function plus a function, to take the derivative of this whole thing, you can just distribute and take the derivative of each. Okay? So again, when you see it, it'll make sense. And here's the big one. To find the derivative of a power rule, x raised to a power, you bring the power down in front and you reduce the power by 1. So the derivative of x to the 5th is 5, x to the 5 minus 1, 4. And we've done this before. So the derivative of, let's say, 7x squared, by this rule right here, the constant multiple rule, is just going to say, hey, forget about the 7, now find the derivative of x squared. The derivative of x squared is bring the 2 down in front, reduce the 2 to 1. So we just get 14x is our derivative. But this should not be the first time you've seen this, so let's go ahead and get started on this. So this assignment starts out with some nice, really simple, quick ones, and this is going to be a quick assignment, but you'll see once we get down to 9 and 10, all this, or 7, looks like 8. Once we get down to 8, we start getting these radicals in there, but the nice thing is power rule handles those pretty easily. So I'm going to do things in more steps than what you should need to do for some of these, but this would be -1, the constant. So f prime of x, differentiate each of the following with respect to x. That's just kind of the language we use. The constant in front of here, -1, then we bring the 5 down, x to the, we reduce 5 by 1. Plus, leave the constant alone, bring the 4, x to the 4 minus 1, so we end up with -5x to the 4th plus 8x to the 3rd. And I think it's pretty easy to see how we could just get from here directly to there. So we're going to do that moving forward. please send a note if you feel like you need to see a little bit more of this, but you can also just go back through that. Okay, so number 2, f prime x, or don't forget, it's the slope formula. For instance, if I wanted to know what the slope of this was when x equals 1, I could put 1 into here, and I'd get negative 5 plus 8. So the slope of this, so the slope at x equals 1 is negative 5 times 1 to the 4th plus 8 times 1 to the 3rd. So it's 3. Why might we want to know that? Well, slope is real world application in most cases, like miles per hour, the number of miles divided by hours. That's what a slope is. It's the change of y over change of x, but y and x are typically in real world units. Miles for y, hours for x. Okay, so bring the 4 down in front. 4x, reduce the 4 by 1 to the 3rd. Now this one shouldn't cause problems because we could just say, hey, what's the slope of negative 2x? It's minus 2. But what would we do here? We'd separate the minus 2. We bring the 1 down in front, so that's minus 2 times x to the reduce that by 1, x to the 0th, but x to the 0th is 1. So this is 4x cubed minus 2. Again, you could just, once you get down to a line, you could just say, hey, what's the slope of the line? All right, number 3. F prime x is 4 out in front. Reduce the 4 by 1. What's the slope of minus 5x? Minus 5. F prime x, negative 5 times the 4, negative 20. X to the reduce 4 by 1 to the 3rd. Nothing to it. They can make these polynomials as long as they want. Really simple. 5 times 2. Reduce the 5. 4 times 3. 12. Reduce the 3. What's the slope of negative 4x minus 4? Or negative 4 times 1. Negative 4, x to the 0th. All right, really simple. You should be able to do 6 and 7 very quickly. In fact, probably some of you have worked ahead on that one, just waiting for me to get to number 8. F prime x, 4 times 2, 8x, reduce the 4. Bring the 2 out in front, 2 times 5, 10, x, reduce the 2 to 1. What's the slope of y equals x? Plus 1. Again, if that's just x, it's x to the 1st. So the derivative is bring the 1 out in front, x to the reduce the 1. Oh yeah, that's 1 times 1. All right, number 7. F prime x, our first derivative, is 4 times 2, 8, x to the reduce 3rd, minus 2x to the 1st, plus the slope of y equals x, 1. Okay, now these ones, highly recommend you write an extra step in here in these. This 5, this 5th root is a power, and this 5th root makes this thing small, makes this x smaller. So this is equal to negative 5x to a fraction 1/5. And now we need to find the derivative of that. So that would be negative 5 times the 1/5, x to the 1/5, reduce it by 1. So that's negative 5 times 1/5, negative x to the 1/5 minus 5/5, negative 4/5. And there's a lot of different ways we could simplify, write that. I'm pretty good with this. Some would say, well, you shouldn't have a negative exponent. So we could write this as equals negative 1 on x to the 4/5. We could go ahead and make that equals -1 on the 5th root of x to the 4th. We could rationalize that, multiply that thing by 5th root of x on 5th root of x, which would give me 5 of these 5th roots in the denominator. 5 of these 5th roots of x would just be x, then I'd have -5th root of x. I'm pretty good with this. So I don't know what the solution key is going to have on there, but all of those are things we should be able to work between. Okay, number 9. So f of x equals x to the 2nd -5. That's interesting. We have pretty much the same problem again. -5x to the 1/5. So we get 2x to the 1st minus 1/5 times 5, 1x to the, again, if we subtract 1 from this, that's subtracting 5/5, -4/5. And then you have a whole assortment of ways you could express that. I'm fine with that. You just need to make certain you're getting these correct. Number 10. 3x to the 5th plus 4x to the 4th minus 3x to the 1/4. And we get 5 times 3, 15x to the 4th, plus 4 times 4, 16x, reduce it to the 3rd, minus 3 times 1/4, x to the, subtract 1 from that, is subtracting 4/4. 1/4 minus 4/4, -3/4. So this is f prime of x. Without that, like back here, that's a problem. Without that, that looks like it's a continuation of f of x. This is f of x. That's the same, just different form. And this is the derivative. This is still f of x here. All right. The rest of the way, nothing really new, just practice, and your homework set is going to just absolutely duplicate this problem for problem. So f of x is 4x to the 4th plus 2x to the 1/4. Maybe you'll get comfortable where you don't need to show that step, but probably not a bad idea as you're starting out. F prime, the slope formula, 4 times 4, 16x, reduce, plus 2 times 1/4, 2/4 or 1/2 x to the, subtract 4/4, -3/4. And wouldn't be surprised if the solution guide has this as radicals, but we're in great shape if we can do this for right now. Okay, f of x is 4. This is x squared to the 1/3, so this is x to the 2/3. And people mix those up. It's like, I don't know, is it 2/3 or is it 1/3? Well, without this 2 there, this 3 makes it smaller. This 3 on the outside, this 3rd root makes it smaller. What makes a fraction smaller? The denominator. This 2 makes the x bigger. So x is being raised to the 2nd power, but we need the 3rd root of that. Okay. Plus 2x to the 1/3, and we get 4 times 2/3, 8/3 x, subtract 3/3 from that to the -1/3, plus 2 times 1/3, 2/3 x, subtract 3/3 from that, and we get -2/3. Okay. Then actually, this little section's easier because we've already got, we've got fractions in some of these, or we've got negatives in some of these, but the rule is just power rule. You don't have to do any of this conversion of radicals into into fractional exponents. We've already got fractional exponents. So y prime, the slope formula, -2 times -1, +2, x to the reduce it by 1, -2nd. -1 times -4 plus 4x reduce it by 1 to the -5th. And I wouldn't be surprised if the back of the book or the solution guide, excuse me, is 2 on x squared plus 4 on x to the 5th. I'd like to believe that we understand where that's coming from. Okay. Notice, if I would have made this -2 on x minus -1 on x to the 4th, and just taken the derivative of these, like in the denominator here, the derivative of x is 1. I get -2 on 1 over 1 on derivative of x to the 4th. I get 4x cubed. I most definitely don't get the same thing as that. So that would not work for us. Y prime, give it a quick try. -3 times 2, -6x reduced by 1, -4. As you might guess, I'll see a -2 pop up for a problem here as an exponent. 5 times -4 minus 20x reduce it by 1, -5. All right. Y prime, 3 times -5, -15x to the 2nd. 4 times 1/4, convenient, 1. X to the reduce this by 1, or 4/4, -3/4. -4 times -4 plus 16x to the reduce this by 1 to the -5th. So you can see how this is going to be a pretty quick assignment for you. Y prime is, what's the slope of 3x? 3. Or, watch, 1 times 3, 3, x to the 0th, but x to the 0th is 1. 3 times 1. Minus 4 times 2/5, 8/5 x, reduced by 1, 5/5, and we get -3/5. Y prime is 3 times 5/3, 5, x to the reduce by 3/3, 2/3. -3 times 3/2, minus 9/2, reduced by 2/2, x to the 1/2. Plus 3 times -5, minus 15. X to the reduced by 1. Don't make it -4. I'm tired of that error. Show me something I haven't seen. -6. And y prime, not y equals, y prime equals 2 times 5/2, 5. X to the reduced by 2/2, 3/2. Plus 3 times 1/3, 1. X to the reduced by 3/3, reduced by 1. -2/3. 2 times -5 minus 10 x to the reduced by 1, -6. And there you have it. Wouldn't be surprised if the homework takes you less time than the notes did. Let me know if I can help.